Okay, so this is the last kind of vector problem I can think of. But of course, if you have any other ones, please let me know. The question is about bearing, and bearing is difficult and forgettable because it's kind of a random skill meant for pilots. And so you guys might be out of touch, especially if you haven't flown a plane in a while. So that's most of you. So here we go. Let's get started. I'll show you how to set up this problem here. Okay. Here we go. Airspeed of airplanes 2. Okay. Even before I draw the vectors, here's how these problems go. The airspeed is one vector. Okay, so we'll call that vector A. Then we have the wind. Okay. And the airplane is getting blown by the wind. So the airplane has a new speed and direction because of the wind. Okay, and that's called the ground speed. That is called the ground speed. Let me go ahead and underline that. Okay, so that is our vector problem speed setup right there. Airspeed plus wind speed will give you the ground speed. Okay. So I think the best way to show you is to draw out these two vectors and work from there. Here we go. Airspeed of an airplane is 250 miles per hour, flying northeast. So if it's flying northeast, exactly northeast, okay, they don't give you an angle, but you can assume it's going to be 45 degrees in between north and east. Okay, exactly northeast. There we go. So that's my vector. You know what? Let's go and quickly set up the vertical horizontal component. Real easy. Oops. That's a vertical. Sorry, that's a horizontal. Here is the vertical component. Okay. On the other side, we have the wind vector. All right, this is interesting. It's blowing from south 50 degrees east. So the way that goes, okay, so towards south and then toward east 50 degrees east, okay. But the wording is really important. The wind is blowing from south 50 degrees east. So the arrow should go at the top there, okay. But this is not the right way of drawing vectors. You want to make the vector situated at the origin. Okay, so let's slide up this vector so it looks more like this. Okay, now unfortunately I can't show that 50 degrees unless I draw the vertical component. Zoom in a little bit. Okay, so I just translated that vector so that the tail is on the origin, which it should be. We want to draw vectors. Okay. In that case, this vector, if I solve this other angle here, this is 50, that means this is 40. That means the true direction of this wind vector is actually going to be 140, right? Supplementary angles. Okay. So now we know we can get the component form of the wind vector. The speed of the wind was 30 miles per hour. So let's go and write that in. Okay, so in that case, here's the wind vector. 30, that's the speed. And then horizontal component cosine of 140i plus sine 140j. Okay, great. All you gotta do to get the ground speed, add these two up. Okay. So now I'm going to show the work where you add the two vectors together. So it's going to look like this. The airspeed plus the wind speed. I'll write it vertically this time as well. 250. This is going to be after I distributed 250 to both terms in the binomial. Okay, 250 cosine 45i plus 250 sine 45j. I'm going to do the same for the wind speed as well. The vector for that. 30 cosine 140i plus 30 sine 140j. The rest is just using the calculator. And so I'm going to save some time. I already typed it in for you guys. Okay, the top line, the 153.8 will be the horizontal component. So 153.8i. And then vertical, 196.06. Okay. All right, now to also do this fast, our goal is to get the actual ground speed, which means we need the magnitude, okay, for this vector. Remember, horizontal components, y over x. Oh, I'm sorry. We're going to use the Pythagorean theorem to find the magnitude. So basically, that is what I'm going to type in the calculator. We'll figure that out. And if you want the direction, it's going to be inverse tangent of vertical over horizontal. Okay, so let's do that. Okay, so magnitude is about 249.19. And the direction will be about 51.89. But is that it? Are we through with this problem? Okay, there's something off about the direction. So here's what we have so far. We have, let's see here. The resultant vector, okay, after we added the two vectors together, airspeed and wind speed, okay, we'll have these coordinates. 153.8 to the right, and then y96. So let's kind of estimate it. The angle that we just got, 51.89, okay, that is the angle between where the vector is and 0 degrees. However, that's not the angle that we want for a bearing problem, okay? Because we don't start from 0 degrees like a unicircle. You need to think about it as a compass, okay? And so we need to write it the angle the same way as he gave us in the problem, using northeast, southwest, whatever. In this case, we want this angle. Okay, so all you have to do, these are complementary angles, so 90 minus 51.89. Type that in. It's 9, give you 38.11. Okay, so the direction in bearing form is north, 38.11 degrees toward the east. Okay, and those will be the official answers. There you go. Whoops.